Hello, everybody. I am sorry about not having class today, so hopefully we will get through explaining things here in the videos, and then you will be all right to do the work. So I am starting on page 8, which has a few more of factoring by grouping problems, where the difficulty level has been dialed up by 1 notch because we have to first factor out a greatest common factor, and then we do the factoring by grouping. So let's look at a couple of those, and then we will move on to the new things that we would have looked at in class today. Okay, so the key with these is you got to remember that it has to be in every single term if it's something that we are factoring out as a greatest common factor. So if I look like at the first term here, there's only x's here. So I know that I'm not going to actually pull any y's out of this because there aren't any y's in the first term. X's, there are x's in each term. And then if I look at 15 and 10, so we have a greatest common factor of 5 for the number part. So 5x is going to be the biggest that I can pull out, because remember this one would have a, we are going to take the smallest exponent, and the exponent that is not written there is 1. So 5x, and then be thinking about what multiplied by 5x would let me get back to 15x to the 4th. So then that would be 3x cubed. 5x times what gives me 15x squared y squared. So we'll have another 3. 1x and the y squared. And the next one, 5x times what gets me to 10x cubed. So that'll be a 2x squared y. And then 5x times what gets me to 10x, whoops, sorry, I'll put the addition symbol in there first, gets me to 10x y cubed, so that would be 2y cubed. There's only one x there, so that got pulled out completely. And then at that point, we can't forget about the 5x, but if this is a situation where you have an answer blank, or if you've got some paper off to the side here, I would recommend, putting the 5x over there so that you don't forget about it, but it can get a little cumbersome to keep writing it in there and having to write the parentheses and all that. So I am going to temporarily not write the 5x. It is still part of the problem. It is not going away. It's over here in my answer blank, but I just don't want to have to write 5x and then nested parentheses and all that. So it's just, I'm setting it aside for the moment. All right, so then I am going to try looking at what happens if I pair the first two and the last two. Here I would have a common factor of 3 and then a common factor of x. So then this would be x squared plus y squared. And then in the next one, I could pull out a 2 and a y, leaving me with x squared plus y squared there. And that is great because that means our binomials are the same. So I can factor out the entire binomial. So x squared plus y squared is one binomial. And then the other binomial is going to be the leftover pieces there, the 3x plus 2y. At this point, I can go to my answer blank, and so that I'm not forgetting my 5x, and then we get the x squared plus y squared, and then the 3x plus 2y. So if you multiply those two binomials back together, and then multiply them through by 5x, you should get back to that original 4-term polynomial that we had. And let's see, let's look at the one at the closer to the bottom here, where we've got the perimeter of a triangle. So hopefully you'll remember that P is for perimeter, L is for length, W is for width. And this is the form that we will often see. It is 2W plus 2L. But we can factor this and say that it's 2, because that's the common factor between those. And W plus L then would be left behind, because if you multiplied the 2 back through, we'd get back to the original. And this is kind of a nice form sometimes to use this, because you can just figure out, add your length and width, and then double it to figure out your perimeter. And sometimes the math is mental math, at least on that, is a little bit easier. So that is the sum total of what you need to do for this one. Is just come up with a factored form. So, and we've talked before, I know I've mentioned it briefly, that the perimeter formula for a rectangle can be in, written in different ways. And so this is looking at the factored form this time. And I apologize, I've got Band-Aids on my fingers here. The dry weather is really killing my cuticles. All right, the top of page 9. So we're given a specific item to factor out. So if I factor 1/7 out from each of these, so left behind would be x squared, then 1/7 times what would give me 3/7 x. So that would have to be a 3x. And then you're thinking about what times 1/7 would give me negative 5/7. So that's going to have to be, a negative 5 there. So minus 5. And at that point, we are not assuming that you know how to do this factoring yet. This is one that actually can't be factored over real numbers, so we're not going to worry about it for right now. But so that would be a sufficient answer because it has followed the directions. And at that point so far, we're not assuming you know how to do those trinomials. We are going to look at the trinomials in our next parts here. So flipping to page 10, so top of page 10 here, factoring trinomials of the form x squared plus bx plus c. So looking at page 10. All right, so when we are looking at factoring a trinomial like this, we are doing reverse FOIL. So when we did FOIL, we got two middle terms there that we added together, which became the bx term. So to go backwards, we have to figure out what's going to multiply to the c value, but add or subtract to the b value. And the way I like to look at that is by first finding all those factor pairs for your constant term c. And that is where I am going to suggest using that t-table and figure out all of those pairs. And then once you've looked at those pairs, you'll be able to figure out which one is going to add or subtract to the coefficient of the middle term. And it's going to give you a few possibilities, and then we'll talk about how we narrow down those possibilities so that you don't have to FOIL out all of a bunch of different possibilities to figure out which one works. We've got some logic. We can use some process of elimination. So if you've played the game Clue or something similar, then you've done that, and we'll use that idea to get rid of some of those possibilities and make our work quicker. So we're going to use the guess and check. So this is not random guessing. We are using this information from that constant term c and finding a pair of numbers that multiply to this, but will add to the coefficient of that middle term. And then we'll have to guess and check, and again, we will use some logic to narrow these possibilities down, but there might be a couple that we still have to check. Okay, so our binomials then will be something of x plus blah and x plus blah, and then those boxes have to multiply to c and add to b. And then we check the answer by FOILing the binomials. All right, so occasionally there, especially when we see the word completely, that is math code for check for all factoring possibilities, which means we should always check for a greatest common factor first. So if you see the word completely, make sure that you are checking. It should be a habit that you start creating where you check for a greatest common factor with all of them. If you do that, it's going to make your work easier in the long run. In this section, we are assuming that the coefficient for the x squared term is going to be 1. So if there's something other than 1 multiplied by the x squared term, then we need to check for that GCF and get that factored out before we do the reverse FOIL. And then if C is positive, so our constant value, if it's positive, then the numbers have the same sign, which means they are either, both addition in my binomials or both subtraction in the binomials. If C is negative, then we're going to have one of each. And since order can be important with which one's negative, you might have to check another possibility here. And we'll look at specifically what that means. So if C is positive, they're both subtraction or both addition. If C is negative, you've got one of each. And that can help you to narrow down those possibilities as well. All right. Now we can also factor by grouping. And what you want to think about then is that when we originally did the FOIL multiplication, that we ended up with those two different middle terms. And we are going to break it into those two middle terms. We're still basically using the same process where we're going to use a t-table, use that t-table to find your constant terms in all of the pairs of factors. So you're going to say, okay, well, here's C. So there's 1 in C, and does 2 divide C? And yes, it does, so on and so forth. And then you figure out which pair of those is going to add to B. And then once you fill them in there, then you can factor by grouping. Now, you may have to flip-flop those two middle terms in order to get the factoring by grouping to work, just like we do when we approach factoring by grouping when it originally has 4 terms. So this is a little bit different of a problem-solving technique, and I think this is one that I had a hard time figuring out when to use this. Was the idea that I could take a term and I could separate it into 2 different terms in order to use a different process. So yeah, so this term is not fixed. You can separate it into 2 terms in order to use that factoring by grouping process. And then of course you always want to multiply, FOIL those binomials at the end to make sure that you can get back to your original polynomial, in this case, trinomial. Okay, we'll do one on this video, and then we'll do a couple more on the next one, because I just don't think we're going to get through. I won't have enough time. These have to be 15 minutes to be free. So, all right, so we're going to start with this one here in the middle, because I know that we all are good with factoring 12. So C, our constant value, is 12. Notice that this is in descending order. Make sure it's in descending order. This will make your life much easier. So 12 is our constant, so 1 and 12, 2 times 6, 3 times 4. Those are all the things that will all the integers that will multiply to 12. So then you look at these and you're thinking to yourself, okay, well, either they add together and those get 13, or they subtract and go to 11. For 6 and 2, they either add to 8 or subtract to 4. And then for 3 and 4, they either add to 7 or subtract to 1. So, and that's because we could have one positive, one negative. This one has a negative middle term, but our final term is addition. Our 12 is positive. So that means both are either addition or subtraction. When I'm talking about that, that's going to be both binomials. So the one that's going to work here is, of course, the 3 and the 4, because if I add those together, I can get 7, which is that middle coefficient there. So then I have a general form here, and I am going to pause right now, and we'll finish in the next one.